Okay, so we need to go through, get our hands a little bit more dirty, doing some examples on the sample proportion and chi-square again. Let's start with example 1. We want to take a sample proportion, sample n equal 200 and x equal 37, and work out a 95% confidence interval. Okay, so 95% confidence, that gives us alpha 0.05 divided by 2, because it's a confidence interval. To the table lookup, get 1.960. Okay, calculate x divided by n, right, which 37 divided by 200. Calculate 1 minus x over n, and feed our formula for the standard error. Okay, we had a sample size of n equal 200. We run through the numbers. 1.960 times the standard error of the mean, which gives us an error, margin of error 0.054. And so we get our estimate for p 1.85 or 0.185, which is probably wrong. It could be too small, so you add the margin of error. Could be too big, so you subtract the margin of error. And so it turns out our p is between 0.131 and 0.239 with 95% confidence. Okay, example 2. We do n equals 1000. We do x is equal to 652. We want a 90% confidence interval. 90% confidence gives us alpha equals 0.1. A confidence interval, you divide alpha by 2. You do the table lookup, you get 1.645. Okay, 652 divided by 1000 is 0.652. 1 minus 0.652 is 0.348. You put this into your formula. Okay, along with the 1000 for the sample size down here. You run this through and you round it out to 3 decimal places, because we've been doing the sample proportions to 3 decimal places. Our estimate for p is 0.652, the x over n, and again our margin of error is 0.25. 0.652 plus 0.25 is 0.677. 0.652 minus 0.25 is, and oops, I made a mistake. This will be, okay, clear that, 0.652 minus 0.025, and this will give us 0.627. Okay, do my correction of the, it won't let me do that, never mind. Let's see from the current slide. Okay, so just remember this was wrong. It's 0.627 arg. Okay. Okay, that's bad. Anyway, all right, example 3. This is a sample proportion, testing the same proportions for chi-square. We have 4 categories. This one had 100 trials, this one 150 trials, this one 120 trials, this one 70 trials. A had 50 successes, B had 70 successes, C had 100 successes, and D had 40 successes. We pool the data and calculate a global probability of success of 0.59. Okay. We put that in the p-hat column. We multiply this p-hat times the 100 times that A tried, gets 59. We get the 0.59 times the 150 times B tried, we get 88.5, etc. And then we put them into the column over here, testing how far they are out of line, getting a total out of lineness of 17.324. The table lookup for the 4 categories, 3 degrees of freedom, is 7.815. 17.32 is bigger than that, and so these are not all the same proportion. Example 4, we have these 4 different classes, and we have these observed number of successes, and we have this particular probability given us. We don't know anything about this except this is the probability model. This total number of successes here, or trials, adds up to 200. We multiply the probability of success in each of these columns times the 200, giving us 26 in the first, 69.2 in the second and the third, 30.8 in the fourth, and 5.2 in the last. And again, go through the mechanics of measuring how far each of these is out of line, and then adding them all up. This gives us a chi-square of 2.976 with 4 degrees of freedom. We do a table lookup. It has 9.688. So we do not reject, because the 2.976 is not greater than 9.488.